Okie dokie. Um, we are. What is this? Eh? 2 viewers already. My goodness. Hey, what's going on? Um, where's my water? All right, so we're gonna do chapter 10 for Book of Monads, but first I want to try and implement the continuation monad again because practice makes perfect. So we're gonna do that right quick. So So basically we'll start with the scaffolding, and then I'm gonna say the thing that made this make a lot more sense to me, and then we will hey bud. Sorry, my kitty distracted me. So this is gonna be nope. Cunt R. So there's something that sort of stuck out to me. I think it was last stream or after last stream to help me through like figuring this out. So we're just gonna put the scaffolding here, and then I'll show you sort of what made sense to me and go from there. Okay. If anything weird is going on with the stream, just let me know. I think I changed VPN providers, so I think it should be fine, but we'll see what happens. All right, so basically if you want to implement, what's up Jabby? How's it going? How's the rest of your evening? I know it's really late, or morning. I think it's morning for you now. You might not think of it that way. Yeah, I'm re-implementing it so that so pretty early. I'm just re-implementing it real quick to make sure I got it. And then I'll move on from there. All right, so here's the piece that I realized made the most sense to me. If you put a hole here, you realize that you need to create this thing, and this piece right here is your callback, right? So if you have a callback here and you just put another hole here, you'll see that you need an R now. So to get an R, if you have an A, you basically just need to apply your callback. So this was the piece that this was the piece that makes it the most obvious. So anytime you're writing these types of functions, you're going to have a callback, and you need, like, that's the first thing that you're going to take always. So no matter what, like if we're doing this one, it's going to be cont callback hole, right? And that hole has type R. So how do we get an R? Ow. Well, we need an A to R, which is right? Which is our callback. So 100% you need to write this. And then the other thing is you need to deal with this F, which gives you an A to B. How do we deal with this? See, I already thought I got this. Whoa, what's up, 5 viewers? How's it going, everyone? We're quickly going to implement the continuation monad again, and then we'll jump right into chapter 10, which is functor composition. Where does this F go? So this function is an A to R. Right? So why does this work? So this is going to take an A to a B. This is going to, oh, right. I just need to do that. This is what I need to do. Okay, so I write this here, and I look at the callback. That's what gives this away. Is it's B to R. So I need to compose these two things to get me a B to R, and then I just stick that out there. That's the key. Okay, cool. Right, so put your callback in here, add a hole, figure out what the type of the callback is, implement the dang function. So let's skip this one because that one's actually trickier. So, and this one's also tricky a little bit. So this time you're gonna have a callback, but you're gonna see that the type of that callback is again B to R. And what else do we got in here? Yep. Wait. Yeah. So this is B to R. So I need this. Nope, wrong button. Sorry. I thought this was supposed to be an A or something. Isn't this supposed to be an A? It was something like this. Nope. Man, this is really hard for me. I don't know why. I wish this wasn't so difficult. I knew giving it a week would make it difficult again. Right? I need an A. That's the thing. I don't have an A. That's why I thought it was something like I already wrote this, didn't I? Thought it was something like this. So that's where do I get an A from? That's an A to R. That's a B to R, right? The distributed data store that we use is a parallel file system called BGFS. I'll put a link in there. BGFS. So Ceph is an option, but we looked at Ceph. The problem is we need parallel. Well, I don't need it, but there are people who use our cluster that need it. Where does the A come from? It's the part I don't understand. Really want to look back, but I don't. This is really tricky for me. I thought I had the intuition, but I don't. This is a B to an R. Yeah, Ceph is an object store similar to BGFS, but it does, yeah, it doesn't have this parallel write functionality as far as I know. It might, but I'm not super familiar with Ceph. I just know that it's an object store. Gosh, this is so hard. Oh, right, I can't do that. Found hole. Is there a hole? There's something about like just getting an A. How do I get? Uh, I'm gonna figure this out eventually, I swear. I need to write it down. Like, I really do need to write this blog post. You manufacture a function to... So strange. Manufacture is kind of a funny way to say that. So you need... Gosh, that's so strange. That's behind my face, sorry. Yeah, it's... I don't know. Like, this part is so strange. Like, you need an A, so you just manufacture one. You're just like... I'm gonna pass... So when we run this continuation, we're gonna get... Okay, so let's put this up here. So run continuation AFBRRA is gonna have type B to R to R. Oh, that seems such a strange thing to do. Then if I apply the callback, I have an R. So, and R has type A to R to R. So it's basically just like passing, you're basically emulating this function. So when somebody gives you this, at some point, someone's going to give you this function, and you need to be able to thread it into the next continuation, basically. Maybe that's not the right way to say it, but maybe it's close. It's definitely tricky. Yeah, I keep saying manufacture in A. That's not what you're doing. I mean, it's just you're just threading through this continuation. Well, yeah, this continuation. Definitely tricky. All right. Let's do the hard one. Maybe this isn't the hard one, actually. So if we go look at this, wrong thing, sorry. Eat R. All right, and then if I remember correctly, we need to there's another lambda in here somewhere, but it's got to be I feel like I'm just going to start doing this every week until it makes perfect sense. I know that's probably boring to watch, but honestly, I don't care. It's important for me to, or I really want to just understand this silly thing. It seems like it's quite useful once you figure it out. Okay, so that's a type R. So that's a B to R. This isn't. I think it's something like this, and then this callback is A to B, right? So if we have an A to B and a B to R, we can do the following. Yeah. And then so this far we know has an embedded continuation, right? So you need to do the same thing here, just with a slightly different place. This is kind of the same technique. That's pretty cool. Okay, and then I just need to put a note at the top of this. Basically, completing chapter 9. This was still difficult. Going to practice occasionally. This has to do with 10. Okay. And let's go back into lib. And let's rename this to eval. and that way we have that library later. Okay, so let's start back in our lib and think about some stuff. So it says the combination of two monads depends not only on the monads themselves, but also on the order in which those monads appear in the type. We can combine the list monad and the maybe monad in two different ways. List of maybe A or maybe list of A. The former type describes computations that have different outcomes, each of them possibly failing. The latter is for computations that succeed or fail as a whole. All right, type constructor composition. In the example heading, oh, okay. In the example heading this section, which is the section we were talking about before, we make use of reader assignment maybe integer. The inner maybe monad is given as part of the result type of the outer reader. This notation obscures the fact that we are trying to combine two monads, reader and maybe, that produce an integer value with possible side effects. To make the connection more explicit, we introduce a new data type that combines two constructors into a single one. Where this type is known as compose. Okay, so let's start playing with that. New type. FGA compose type operators. Why is that coming up automatically? I don't think that happened before. And also, that's working now. That didn't work before. I'm not sure why. This is cool. I actually didn't know you could do this. Okay. Now we can write the type above as reader assignment compose maybe integer. Weird. So reader, really reader T. I might not save this, it's just discussion. Okay. Anyway, we go into the next section. I'm not gonna, let me ignore this. Maybe it'll come back, but I'm not sure what that little aside was about. Oh, wait, I lied. I need it. Get rid of this. Okay, so before we delve into monads, let us consider those cases where there are no problems. If we know that both f and g are functors, we can make a new functor out of their composition. The function that we need to write for such an instance has the type We can write instance functor f functor g functor f g oh wait, I can use f here, right? It's a different f. Compose ooh. Fmap f x. Isn't this the same as this? Okay, that's what I thought. It just looked weird to me that way. Because we're basically, you know, we're trying to get to this A, and we know that these things are functors. Hey, what are you doing? Don't do that. My cat's about to start being really bad because it's 9:30, and that's when he starts being really bad. So there's not much I can do about that. I'll do my best to stream until 10:30, but my girlfriend's not around today, so I may have to deal with this cat. We'll see. He's more like a dog. He needs a lot of attention at night. All right. Stop it. Please stop. So he likes to play. Here, you should meet him because he is super cute at least. Oh, okay. Or not. He doesn't want to be held apparently. He just wants. Come here. Will you come up here? Meet the people. There we go. Found you. Make some noise. You can't go up there. Hey, he's not having it. I tried. That's Andre 3000. Okay. Anyway. Do-do-do. Okay, so we can reuse the idea of mapping twice to obtain an instance for the composition of two traversable functors. I don't know why we're talking about traverse all of a sudden, but okay. Let's do the following. Traversable G and probably functor. You really don't need this? Interesting. Traversable. reverse. The constraint foldable is no smaller than the instance head. The hell does that mean? That means what's happening? Huh? Could not load module lib. Haha! It's in the wrong place. There we go. My bad. Bad. Alright. Undecidable instances. You got it. Okay. Poll. Is it just the same thing? No, it's not the same. That's a weird... That is not something that I want to explain. I'm not sure that I could. What's up, bud? I might be able to explain the applicative. Alright, so it says... Stop. This cat is being bonkers. He's cute, though. You guys want to meet my cat? I see a bunch of people viewing, so we'll keep you around by showing you a cat. I diddle myself. My goodness. What a Twitch name. Here's my kitty. It's Andre. His name's Andre 3000, and he's nuts. As you can see, he's being a little crazy right now. Thanks for the follow. I'm gonna call you Diddle. Andre 3000, and he needs attention right here. So we'll see if I can handle this. This little kitty. He's a little crazy. Oh, this is behind my head too. I'm sorry. So it says, just for reference, it says the only remarkable thing about this code is you need this F map here. I'm not sure if that's the only remarkable thing. This seems pretty wild to me. But again, you know. What do I know? So the next one is basically applicative. G. Ooh, I keep writing this. Applicative. It's gonna be compose F compose X. Compose FGB. So is this just so wait, no, because F is this F is inside of two F maps. So this is where you need probably some wild shenanigans like uh I don't know, I'm just guessing by the oh well. That's the first one. Okay, so we got F. I want to see if I can figure this one out without looking it up. Not that it's I'm being asked to do it or anything. Right? So this F over here is basically F of G of A to B. And X is F G A. Right? So I need to F map I need to F map apply oh wait no. All right, so if I F map apply onto this, there's like another level of F mapping that needs to be done. That's the hard part. Eh, I'm close. Wait, isn't this right? It is right. It says a redundant bracket. Nice. Nice. I had it. I was like, that looks right. What's going on, Oren? How are you? I'm proud of myself for figuring that out. What's new? Not much actually. A pretty quiet week. Thus far. My girlfriend won't be around this week, so um that's kind of boring. But hanging out with my cats, writing Haskell. I finished the alpha version of my one of the tools that I'm writing at work. So yeah, it's pretty good. That was in Haskell as well. What's going on with you? On Thursday, we're gonna build a web form somehow, and then we can just fix this. Man, I can't believe I figured that out. That's awesome. Good job, by the way. Thank you. Thank you. I assume you mean on the little tool that I made today. It's basically a really bad written tool, but it starts as a bad written tool and hopefully we'll get nicer. Man, that's cool. I've never seen this before. Well, actually, no, that's not true. We've seen this kind of pattern. Less girlfriend, more Haskell. It's sometimes it's okay, sometimes it's not. That's a funny way to put that. I wonder if this would look better this way. Eta reduce. Oh, right. We don't need. We can just do point free there. Man, this is cool. I'm a big fan of this right now, and I also a big fan of the fact that I realized that I could do it. That's pretty awesome. All right. Okay. Not exactly sure why we're doing this right now, but G. What's up, crazy kitties? So empty. So I think this comes from control applicative. Oh, dir. Yeah, now we have. So really sure what's going on here. Oh, and now the cat's shutting the door. Watch the door behind me. See this? It's the cat. And not locked yet. But he likes to lock himself out. Yeah? Gonna lock yourself out? Hang on, I just gotta. I put the squirrel in the way, at least he can get back out. Okay, so this is FGA, and each of these are FGA. Not really sure what's going on here. Is it real? Okay. I wasn't expecting it to be that easy. I don't really know what this means, but kind of a weird one, I would say. Sorry if that was not able to be read. Okay, so in fact, we don't need to do anything from the inner functor to write a type correct definition. All right, so the point is that this is easy, I think. I think the point is that this is very easy when you have functors, because functors compose. However, that's not the case for monads. So as you might have guessed already, it's not possible to take two monads f and g and compose them into a new monad in a generic way. By generic way, we mean a single recipe that works for every pair of monads. There are some pairs of monads that cannot be combined easily, or I'm sorry, that can be combined easily, like two readers, and others that need a bit more work. Like lists and optionals, as shown at the beginning of the chapter, there's no uniform way to combine any two of them. What are you doing? Oh. I told you he was going to be like a menace. He's a menace. What's the matter? I'm going to hang out with you in a little bit. We might end the stream a little early tonight because, well, I mean, we only have a half hour left. We can probably finish. All right. So in order to understand why you can't compose two of them generically, we're going to consider in greater detail the idea of monads as boxes. So, okay, so let me just put this up here. I want to do this, and we'll do stack REPL. So info monad. Okay, the key here is all right. So the composition for return is totally fine because the pure, you can compose applicative, right? So if you can compose applicative functors, then you can compose this return. However, the bind operation is your problem. That's what it's pointing out, is something is wrong with this that doesn't allow you to compose. Excuse me. So let's go back in here and just say you basically need the following function. F G G A. What? Oh, this is a different, I'm sorry. This is, wait, where's join? Is join defined? You know, I never noticed this before. Minimal bind. which I assume means that the default implementation for return is just pure. And I don't need to write that ever. I didn't realize that. So now I know that if pure is just return, I can just not implement it. Anyway. Also, I can implement fail directly in the monad itself. That's what it was saying. Oops. What did I just do? That's what it was saying with preludes fail. This is prelude fail. So I can actually just implement fail. Learn something new every day, folks. What are you doing, crazy cat? He's crazy. Okay. I don't know where this join function comes from. Does anyone know? Join. Okay. So the way they write this in the book is that it's a part of the interface for monad, but it's not. It's a separate function. So there's a lot of things that changed between, you know, the versions that I'm working with and these sorts of things. But hey, kitty, can you hear him? He's pretty loud. So basically, we want to do something like that. So if we specialize that, it would be like F G like this. Yeah, and just to, well, written a slightly different way. FGA. I think I remember having or reading this somewhere else, but yay. FGF. Nice. Okay. In a monad, we only have methods that add layers of monad, return an fmap, and methods that flatten two consecutive layers of the same monad. Alas, FGA, this thing here, has interleaved layers, so there's no way to use join to reduce them to FGA. This FGA here. As you can see, the reason why we cannot combine two monads is not very deep. It is just a simple matter of types that don't match. The consequences are profound, since it tells us that monads cannot be freely composed, which is, you know, a huge discussion in this topic. Excuse me, in Haskell. Probably a better. Alright, so one way to work around this problem is to provide a function that swaps the middle layers. So we could write the following: GFA FGA sequence, aka. This way we can first turn FGFGA into FFGGA. Okay, so when such a function swap exists for two monads f and g, we say that there is a distributed law. Okay, so I should write some stuff here because f and g are interleaved. Stopped in 8. Chapter 8, I think you mean? Yeah, we are in chapter 10, actually. just talking about composition. I really wish there was a time attached to when you sent that. But yeah. Yeah, so now we're into the good stuff, I think. Like, chapter 8 is when the good stuff starts. Everything before chapter 8 was kind of boring as far as I'm concerned. But I think that's because I read HPFFP. If I didn't read HPFFP, it would have been a different story. Freely compose monads. If we can write this function, we have not done transformers yet, not in this book anyway. So we're gonna do those soon though. We wrote a transformer by hand earlier actually. So essentially we wrapped a transformer. Okay, so this is like a monad transformer of another one. Well, it's not actually. Basically, we allowed ourselves to write the composition for evaluator. But that's not the right either. Maybe I'll get this correct at some point. How do I say this correctly? I'm not sure how to say it correctly. Anyway, we wrote some wild code earlier. It wasn't that hard, actually. I thought it was going to be a lot harder. The types kind of just send you down the right path, so. Oh, also, I don't need... What I can do is actually move this here. I don't need this anymore. And then I can get rid of this and this, I think. Right, so should get Chatterino. Yeah, that's a good idea. Also, hi, Andrew. A lot of people are using Chatterino right now, so I probably should just use it as well. And there is can you see him? Hey, bud. I don't even know how he got up there. Did you see him jump? I didn't even notice. We really want prelude fail, and the other option is control monad fail. So I just need to delete that. And then I think that'll get rid of that. Yep, now he's throwing stuff on the floor. He's such a lovely cat, isn't he? Anyway. If we can write this function, there is a distribute. He didn't drop Hodor. Hodor is actually on the floor over there. At least I think you're going for Hodor. He doesn't like point free apparently. Hopefully you can see him pretty good. I don't know. Oh, there he goes. He's out. He's funny. Types. So one thing I'm starting to feel more of when I think about this, or when I think about like reading this. Oh, sorry. You can't really read this very well. So in the book it said, if we can write this function, there's a distributed law for those monads. They don't have to be monads. Well, maybe they do have to be monads if you can write swap, but maybe. Now I'm not sure. But either way, I mean, F and G are not necessarily monads. They're just types. They're Ow. And yeah, so the point is they're not necessarily monads. These F and G's where we're writing everywhere, they're not necessarily monads. So you shouldn't call them monads. Or they're not just monads, they're also other things. So it seems to me like you shouldn't write monads there. Maybe I'm being super pedantic, and I might be being pedantic incorrectly, but it just seems like monad isn't the right word there. But what do I know? Okay. Um, one example of a pair of monads that admits a distributive law consists of two readers. So essentially, I can write it real quick. Does this look familiar? I think it's flip. So for example, reader is distributive. Okay, cool. This shows us that we can compose two reader monads into a single one. In fact, this is not an unexpected result, since having two pieces of data R and S in some environment is equivalent to having a pair RS. All right, yeah. We learned that at some point. There's an isomorphism between R to S and tuple. Well, I guess it's RSA, tuple RSA, which is just the curry and uncurry functions, right? Fun. We're learning. Some monads even admit a distributive law with any other monad. The simplest example given is given by maybe. We can move maybe from the outer to the inner layer of a monad composition by using the following definition for swap. Sometimes I try and write these without looking at the book just for reference, if that's not clear. So this is oh, sure. Sure. Then in theory, oh wait, no, that's yeah. Mm-hmm. Okay, so it says, but note that we cannot in general write the dual function that takes m maybe a and returns maybe ma. The you can't write the opposite of this, apparently. Okay, so the writer monad admits a distributive law with any other monad from writer WM to M writer W. Okay, so this is now an exercise. So let me put this up here. Exercise. So we're gonna write swap writer yeah, that's exactly what's going on. Basically that, you know, yeah. The problem with all of these examples, um, is that writer is kind of hard to use. So what if we do it like this? Control monad trans writer. And then import control functor identity. Okay, well, the types work, so that's convenient. So let's think here. I gotta remember how writer is defined because I just don't remember. I don't know which one I get by default, but let's assume it's the lazy one. Hang on, I think my cat just broke something. Be right back. I have no idea what that was. I don't know what he did just then. The new Vim terminal emulator. What do you mean? Vim Terminal emulator? I have no idea what you're talking about. This one? What? Weird. Neat. Term. Uh-oh. How do I get back? Control W doesn't do anything. Yeah, I don't know how to get back. Control W. Yeah, this is not quite working right now, but I'll play with it later. I don't want to. Yeah, see, like I can feel it being a little strange. I'll mess with it afterwards. But that seems interesting. I don't know how to use it effectively yet, but you know. Okay, so here we're going to take a compose of something. And we need to write a compose of something. Hello? Oh, that sounds cool. That sounds really useful. I couldn't get back into normal mode. I was hitting escape, but nothing was happening. I do want to play with that. I think that could be really interesting. Uh, hey, are you a bot? Question mark. Sometimes when there's questions like that, it's a bot. But if you're not a bot, then hello. Vim users discovering why people have used Emacs for years. Hey, what's up, Michikis? How are you? That's really funny. Ow. Oh, yeah. Bot. Hey, bot. Everybody say hi to the bot. I thought it was control functor identity. maybe it's control monad trans identity. Yeah, that's fine, Mitch. I'm glad that you're chatting. I always like when you're around. I know you're probably, yeah, science technology forever. I don't even want to ban the bots. I think it's hilarious. They write, I found your Twitch channel. Twitch is spelled incorrectly. Um I loved your stream, like past tense, and it has my current title in it. It's just absurd. About to do design and arts for your streaming. Design and arts, huh? Nice. It's just really funny to me. If people want me to like ban those people, just let me know, but I think it's hilarious. Just understand that if you don't understand that's a bot, I don't know what to do with to do with you. Oh, data functor. I wrote control functor. Whoops. Science technology forever. All right. Now we're failing. Maybe we should just write this in the um like just using the I'm definitely gonna look at that Orin. It looks interesting. Um oh okay. Writer. Excuse me. It's just AW. So let's just write okay, fine. Let's do it this way. Uh new type. Writer. WA. Okay. And then this can be writer. I think. What is this complaining about? Um, Science, technology, forever. I feel like I need to save that somewhere. Oh. Do I need... Like so. There we go. Just needed to look at the types. And think more carefully. Okay. So... this A is a monad writer W, which means we can bind oh no, it needs to be a monad writer W, of course. Leave that there. What's the type of W? So I tried to use Spacemax for a little while, but the reaching for the Control and Alt keys started bothering me pretty quickly. Not that I'm like an expert Vim user or anything, but you know, it'd be nice if I was better at it. So if I always do that. If I run writer this, I have it set up in Nix, which gives me all the power I need. We're using Spacemax in Vim mode. I think I was using it in Vim mode, but maybe I misunderstood, you know, maybe I misunderstood it. Like, I probably was using it wrong. Like, that's something I do all the time, so. What's a just? Oh, so actually, Oren, this brings something up that I want to show everyone before I forget, before we're done, because we're actually supposed to be finishing here soon. Yeah, maybe I misunderstood how it works. All right, so just so everyone knows, I'm not gonna show you that calendar. I don't think there's anything important on there, but on the 16th, which is November 16th, which is a Saturday, at 10 a.m., I'm going to co-stream with Jappy. So if you don't know Jappy, you should check out Jappy. Twitch TV. I'll write it in here. Twitch TV, Jappy. And he's going to teach me how to use Nix. We're going to do a 2-hour stream. And you know, you could teach me something too if you're interested. So that's kind of this weird idea that I had recently. that I want you to teach me something about Haskell. So we're gonna do that on November 16th is gonna be the first one, and we're gonna like basically get this pull request into shape, this one, and then it'll be like episodes. Oops. It'll be like episodes. So the first episode will be Nick's, and we're gonna put it on YouTube, and we're gonna have basically like a lesson for folks to do. So anyone that's interested in doing, you know, this 1 to 2 hour Nick's tutorial could just do it from this Teach Me Something. So that's kind of the ultimate goal, is to have other people teach me stuff about Haskell, or, you know, different things, and then also be able to provide tutorials for the community to do as well. So if any of you are interested in co-streaming with me, it doesn't have to be during this time. We can schedule it outside. So that was kind of the idea. So if you have something that you're particularly passionate about, a library or whatever, yeah, try and do it. I have no idea if it's gonna work, right? Like that's a pretty tricky thing to ask you to do. Tricky in the sense that, you know, it requires a lot of your time, and it doesn't really require much of my time. Like, it doesn't seem like that, but I want to spend a lot of time taking what we do and really, you know, make it into a lesson, not just, oh, here are these things. Like, make it into a, this is really how you get started with X. That's kind of the idea. So we'll see if that actually happens. Yeah, I don't know what he's going to cover either, so we'll have to see. Is this... Oh, pure is not going to work here. Yeah, I have no idea if it's going to work, but Jappy was interested in trying it, so I commend him for trying. And we'll see if we can make it something. I want to make something as well. Like, I want to do one on the continuation monad, so I'm hoping that I can do that at some point. Pure writer actual type expected type actual type. All right, so that's basically, I'm not flipping anything, I'm writing the exact same thing. I need to... Yeah, I'm actually kind of excited for Nick's. I hope that he can really help me with that, because I think it will be really cool. So what does it mean to have... What is the type of this again? It's a writer with a monad inside of it. Right. So this A has a type MA, right? Yeah. So I need the monad outside. So this is really a monad of A. So we're going to embed the monad. And it's actually like this. Hmm. C, writer. And then can I write this in a slightly different way? Yes, I can, because I can write run writer C like so, right? Apparently I cannot. No, because I have to bind across first. So it's a little awkward. I'm not sure if there's a better way to do this. Maybe there's like a lens or something. If Jappy was here, he'd be like, you can use lenses. Apparently you can use lenses for everything. I didn't know that. Or maybe there's an arrow. I don't know. But I think this is right. I'm gonna try and write swap reader, and then I'm gonna be done for the night. Well, new type. Also, the Canucks are playing, so I want to watch them. If anyone didn't know this, I'm a pretty big hockey fan, actually. Also, I forgot to tell you guys, somebody stole my pumpkin. Like, I put my pumpkin, I carved a pumpkin. Here, check this out. It's actually pretty good. Who knew that my art medium was pumpkins? Check that out. But I had this pumpkin, right? And I put it on my front porch, and I put a light in it like this. So this was it literally out in front of my house. And somebody stole it. Who does that? Freaking monsters. Thank you. It's the Cheshire Cat. I had to put I broke it a little bit right here. I cut just a little bit too far. So this little piece right here, you probably can't even notice it on the stream, but it's a little piece of duct tape. Yeah, I guess it was like almost rotting though. So like this piece right here was starting to like fold in on itself. So I don't know why you would want to steal it at that point. Like the first night when it was fresh, it looked really nice. I actually really enjoy carving pumpkins. I don't know why. I do a decent job at it anyway. So anyway, I thought that was so strange. Like, why would somebody steal a dang pumpkin? I have no idea. But they stole it. All right, so now we're gonna write basically the same thing, I think. Reader, but the other way. So monad colon reader R A to reader R monad A. Swap reader compose C equals compose $ whole. Okay. The joys of having a 9-foot fence with barbed wire. Yeah. This apartment has been surprisingly problematic with stuff like this. I don't know if you guys knew this, but someone broke into my house at one point. And so now I have a like a alarm system, so that won't happen, hopefully. And then somebody stole my pumpkin. Obviously, stealing your pumpkin is a lot less problematic, but you know, it's been a little problematic living here. I don't know what to do. So this is just a monad, so we can just bind and this gets me my reader, so I can just do that here, right? So let f run, wait. Yeah. I don't know what to do about it. Hey Mitch, question for you actually. I was thinking about this a few days ago. Do you know where Mathematical Way went? I feel like I haven't seen him in a while. Just being busy? Fair enough. Yeah, I mean, I kind of figured, but I just was wondering if you knew anything. I didn't know if you knew him at all or anything. I felt like I haven't seen him in forever, and it's unfortunate. I want more Haskell streamers. I suppose the good news about that, or well, the only positive thing that's happened since that is that Jappy is streaming a lot, so I can watch Jappy when he's not around. F just on stream. Fair enough. So we need a reader. Jappy's great. I really like Jappy. Something like this anyway. He's doing some web dev stuff and I out and ping him if I notice Discord or something. Yeah, I mean, he might be lurking right now. I actually have no idea, but I just, I liked his streams. Let's see what we got here. Actual type. Where is that? Oh, I need to embed a monad. That's not gonna work. This isn't right. Hang on. This just isn't right. Okay, let's back up. So if we put a hole here, we need a compose. Let's use that hole actually. And we need a reader R to MA. What is this C again? Whoops. Yeah, I think it, anyway, Oren, if you see the co-stream, if you don't get a chance to check him out before our co-stream, I think you'll enjoy what he's doing. I mean, I think you just like watching Haskell, so yeah. So I think the reader has to go here, but the question is, how do I get, like, it's got to be like reader, something like this, and then we need to embed the monad. Oh, I see. Okay, so it's gonna be like pure fmap run reader C, I think. No, because run reader C. Keep writing the wrong one. Yeah, this one's tricky actually, because I can't. I need to get. I need to get that reader. But I also need the monad. Is this right? How do I get the reader? This syntax is tough. Yeah, you aren't joking. It takes a while to get used to, but honestly, saying once you get used to it, it's like I can't look at anything else. Like now when someone shows me code in other languages, I'm just like, what is all this noise? Like, why is there so much syntax here? Um, so, but I understand, like, that first initial dive into Haskell was pretty brutal. But now I find myself thinking other languages just have way too much syntax, which is really funny to think about. But it's very tricky. It's very tricky. So, how do I do this? Because I need to get. Oh, yeah. So that is this. So basically, it represents the composition of f with g. So, imagine a function g that takes an a, and then it's just its composition. That's all. But and that is only happens at the type constructor, right? So there's this type constructor, this thing, and then a data constructor called compose, which is actually building your compositions. Yeah. And you can just define these. I mean, it's like you don't have to. There's no. It's not difficult to define this kind of stuff, which is really nice. Right now, my biggest problem is that I need to figure out how to get this C. I keep writing the wrong thing. So this C has this reader embedded in this M. Think of it like a box. And I need to unwrap the box to get the reader, but there isn't a convenient way to unwrap a random box. So I don't know how I get this reader out. The idea here is that we're basically swapping the outer F, the F in the G, right? That's what we're doing. So instead of, we're taking FGA and creating GFA. That's exactly what we're doing. Or well, trying to do. But I don't see how I unwrap. I don't see how I unwrap the outer one. If I use bind, I have to put in another monad. So let me just explain what I'm saying there. This bind function here, I was thinking about using that, but I have to embed the same monad. So that's what this pure thing is doing. So I don't know how to unwrap that randomly. There's really no way to do that. Oh, well, yes, there is. Wait, no, it doesn't work. I was like, do. No. And if I remember correctly, this doesn't work at all, right? Oh. Yeah, see, that just complains because it's not possible. I feel like I'm misunderstanding this question. Or is this supposed to be a... Wait, no, that doesn't matter. I really want to learn a Lisp at some point, but I'm kind of too far down the Haskell track at the moment. If Lumi was here, he would tell you that Clojure is the best. He's a big fan of Clojure, I think. I can tell you that he likes it quite a bit. I'm not sure if he's still lurking, but he really likes it. He also knows a ton about it. It's not like he's just advocating it for no reason. I don't know what to do here, folks. I don't see how I do this. So it's, okay, let me read the question to you, and let's see if someone can rock this, I guess. So the writer monad admits a distributive law with any other monad from writer W. So this is this one. Writer W compose M to M compose writer W. The reader monad admits a dual distributive law from M reader R to reader RM. Why does it say dual distributive? Does that mean I'm supposed to do it the other way? What does dual distributive mean? No, I did not mean double. Is the word dual in here? No. Because if it means the opposite, then I think that I can do it. If it's reader RM, I might be able to do it. But I don't see how I do it this way. Because there's no way to unwrap an arbitrary box. Let's see if I can do it the other way. And then maybe that's like enough to all right, and then what's the type of C here? Actually, isn't this the same problem? Well, let's do it this way. So, it's gonna be something like this. F oh, sorry. Reader. What's up, Wong? I'm gonna want Wangasta? It's probably just one. It's either just like one word, Wangasta, or one Gasta. Not sure. But yes, stateless and immutable is really important. We're a big fan of those things. When possible, anyway. What's going on? You're new here. Are you a Haskeller or just interested in FP? Actually, same question as Satan. I'm not sure I actually asked that. Not runtime exceptions. We can run compile. We can deal with compile time exceptions. Well, I guess they're runtime, but they're embedded in the type system. JavaScript for work. Cool. Cool. I'm a little stuck here because I don't see how this works. Either way, in fact. Yeah, you can use maybe monads, but there's actually also there's ways to throw exceptions, but also catch them. Like catch exceptions that you're raising yourself that aren't actually runtime exceptions. Yeah. There's also like either as well, which is just a little different. Satan knows nothing. I primarily use C. What are you using C for? Embedded stuff or something else? Out of curiosity. I don't think that this is done like doable. I don't see how you do it. there's no way. A lot of things, fair enough. There's no generic way to get this function. Monad M. You need this function. I suck at FP, but I love lambda programming. What do you mean by lambda programming? Like using lambdas? Not exactly sure what that means. What's up, perfect timing? Thanks, Moobot. My bit rate has been wild today. I'm not sure what's going on. I don't know how to do this one. Maybe we should Google it. We swap M reader Haskell. Okay, yeah, so I mean that's FP, map reduce, etc. Oh, that's okay. You don't have to be amazing at uh pure Haskell. I mean, that's like a, you know, it's just something that I want to learn. That's the only reason I'm doing it. I hope that's a joke. Maybe I can look this up a different way. Exercise 10.1, Book of Monads, Haskell. Prologue. I don't know that I'll do prologue. How about this? Book of Monad, Haskell, Solutions, GitHub. Nice. Let's see if we can find it. Oh, only get to exercise 6.1 here. Book, Haskell programming. Monads for drummers? I don't really see a solution to this. I really don't know how to do this. I'll be completely honest with you. I don't see how you make this happen because you can't unwrap a monad. There's no way to get this A. I need that A. So, yeah, so that gets me F, right? If I run reader, I get this function. I need this function. I need to unwrap what comes out. You see what I mean? And I think technically the function or the thing is supposed to be like this, and it's kind of the same problem. Right, so if we have this, Wait, no, that's not right. Isn't it the other way? Yeah, that's what I was thinking too, but bind doesn't help me here. And the reason bind doesn't help me is that I need to embed it inside the same monad, right? So if we just look at the type of bind, let's look at it because it will help. If we look at the type of bind, hang on. I have a monad of A, a virtual machine, and I need to embed the M back. So I'll always end up with that M, which is the problem. I need to get rid of the M. And the only way to do that is to like run it. And the only way to do that is some sort of unsafe function. So I'm very confused at how I do this. I'm going to need to ask because I truthfully don't know how to do this. And maybe you can't. I really don't know. I'm very stuck. Even if I flip the order here, I had the exact same problem because I'll have basically a function R to MA that I can't pull out. Yeah, I think that, well, but as far as I'm concerned, the only way to implement this is via a unsafe function. But I don't want to implement that. I'm not sure how to do this. That's cool. You want to share your programming language, I would hang out with that. Or check it out. Hang out with it. Yeah, that makes sense. I'm tired. So I think I'm done for the night. I need to ask somebody about this because I'm super confused at why this doesn't work. I'm very confused at why this doesn't. Yes, a weird thing to say. I need to sleep apparently. I don't quite understand what's wrong with this. I think I'm misunderstanding the question, but I don't know why. So anyway, that's it. So for reference, that's the book we're working on. Like you can just get it on Amazon if you want it. But you know, you don't need to get it, obviously. You can also just check out the GitHub for what I'm doing.